Namaste and a very good morning to all of you. My name is Mithun, and in today's video, we'll be looking at what are the most common transformations that we apply when we work with marketing data. When we talk about marketing data, we think of sales, price, resale value, and other variables related to the product. Mostly, when we take the raw data might not give us good results. So when the data does not produce good results, the question is, can we transform the data? How do we transform the data, especially marketing data? To get the answers for these questions, please watch the rest of the presentation. I'm working on SPSS. Let me pull out a file by going to the file menu. I will choose the recently used data. And right at the top, you see the file which is called as car sales. The moment I click on this particular file, you can see the file called as car sales open up. You see four variables. The first variable is manufacturer of the car. Second one is model of the vehicle, sales value, and the price. So the first manufacturer is Acura. The model is Integra. The sales value is $16,000 and the price would be $21,000. What is the sample size in this data set? When you look at the sample size in this data set, the sample size is 157. Now, you see two scale variables, namely sales and price. If I want to check for the normality of these two variables, how do I do it? To check for the normality of these two variables, I will click on the Analyze menu, choose the second option, Descriptive Statistics, and we have two different plots, the PP plot and the QQ plot. I will choose the PP plot to verify whether the variable sales and the variable price is normally distributed. So sales and price, the default distribution is normal. I want to check whether the data follows normality or not. Let me click on OK. The moment I click on OK, in the output window, you see the output being displayed. Let me choose the normal PP plot of sales in 1000. And this is the distribution of the data that we have. Now, what is the inference that we can draw by looking at the normal PP plot of the variable sales? Had the variable sales been normally distributed, the data points would have been lying along the 45-degree line. I repeat, the data points would have been lying along the 45-degree line. But you see, these data points are not lying along the 45-degree line. Hence, it indicates that our variable sales is not normally distributed. And when the variable is not normally distributed, usually parametric tests do not give us a reliable result. This is as far as sales is concerned. Let me proceed to look at the second variable, that is price. Look at the distribution of the variable price. Had this variable been normally distributed, again, the data points would have been lying along the 45-degree line. Since the data points do not lie along the 45-degree line, it means that this particular variable is not normally distributed. So both these variables, sales and price, are not normally distributed. And as I mentioned earlier, when the variables do not follow normality, we cannot use parametric tests. We have to use non-parametric tests. And by definition, non-parametric tests are not as robust as that of parametric tests. But here's the deal. Can we apply some kind of a transformation to the existing data so that the variables are forced to follow normal distribution? How do we apply these transformations? To discuss this, let me take you to a book that is written by two authors, Chris Chapman and Elia McDonald-Feed. This is a very good book. The title of this book is R for Marketing Research and Analytics. I repeat, the name of this book is R for Marketing Research and Analytics, written by Chris Chapman and Elia McDonald. I find this book very, very useful. It is roughly 492 pages. It's a good read, especially if you want to master R and if you are working on market research data. Now here, I will not be going into every chapter of this book, but I specifically want to take you to transformation. And when you look at page number 101, they mention the different kinds of transformations that you can apply for marketing data. Let me zoom this in so that you can have better visibility. You can see here, table 4.1, common transformations of variables in marketing. Here, to the left side, they list the variables that we usually come across in the marketing field and what is the appropriate transformation that we can apply for these variables. Some of the variables that we usually see in marketing field would be unit sales, revenue, household income, and price. And he says the most common transformation that is applicable here would be log transformation. If you see variables like distance, the appropriate transformation would be to take a reciprocal or to simply square the variable and then take the reciprocal. If these two transformations do not work, you may have to stick to the original transformation, that is log of the variable. Thirdly, if you're working with variables like market or preference share based on a utility value, you can take the transformation e power x divided by 1 plus e power x. As a general rule of thumb, whenever you're working with right-tailed distributions, you can either use a square root transformation or a log of x transformation. And finally, if the data is left-tailed, we can take the square of the variable. So I find this table very, very useful. And therefore, based on the suggestions that the authors have made, we can try out some of these transformations. As he says, unit sales and price, we can apply log transformation. So let me go to my data set. Our original data did not follow transformation. So let me compute a new variable in SPSS. How do we compute a new variable? We can go to transform menu and then choose compute variable. Here, what I will do is I will simply say ln underscore sales. This is the new variable. I will be using the transformation ln, open parenthesis. I will push the variable sales by using the arrow and close the parenthesis and then simply say OK. What this function is basically doing is it's applying the natural log transformation for the variable sales. Let me choose OK. I will go back to my data set. You can see here a new variable called as log sales has been computed. Now, can I do the same thing for the second variable price? I can go to transform menu, choose the compute variable, and here I will just replace the word sales with price. And instead of using sales here, let me remove the variable sales and push the original variable for price. What am I doing here? I'm applying the natural log transformation on the variable price and storing it in the new variable ln underscore price. Now, let me just click on OK. So this is the new variable that I have after transformation, log sales. This is the original variable for sales. This is the log transformed value for sales. Similarly, this is the original variable for price, and this is the log transformed value for price. As the authors have suggested, let us check whether the new variables follow normality or not. To do this, let me click on Analyze. Choose the second option here, Descriptive Statistics. And within this, I will choose the PP plot. These are the two original variables. Let me kick these variables out and choose the variables log transformed sales and the variable price. Once we select these variables, Let me ensure that it is showing normality. And now let me choose the option OK. Here, SPSS shows the output, normal PP plot for log sales. Look at the beauty behind this transformation. These data points are now lying more or less along the 45-degree line, indicating that the normal PP plot of log sales is more or less normally distributed. I can't say it is exactly normal, but it is approximately normal. If you recall the original distribution of the variable sales, this is how the original distribution of the variable sales looked like. It is lying nowhere along the 45-degree line, indicating that the original variable is not normally distributed. Now that I have made the transformation, let's look at the normal PP plot for log sales. You can see more or less the data points are lying along the 45-degree line. You see small departures, but you can ignore those departures and conclude that after transformation, the variables are approximately normally distributed. Let us do the same thing for the second variable, which is price. Now, here you're seeing the normal PP plot of log transformed price. Again, here, this is how the distribution appears. It is lying more or less along the 45-degree line. At the center, you see some departure, but it is a lot better than the original variable. How was the distribution looking for the original variable? When I look at the PP plot for price in thousands, this is the distribution of the original variable. You see significant departure from normal distribution. When I take the transformation, the log transformation, and check for the distribution, the variable now looks approximately normally distributed. So this is how, when you're dealing with marketing variables, it helps to transform the variable and then build the model and then do your hypothesis testing, because many times the original variable do not follow the prerequisites of statistical tests. So with this, I have come to the end of today's presentation. Today, we have looked at what are some of the important transformations that you can apply, especially for marketing data, and how we can apply these transformations using the compute variable option in SPSS. And once you transform, how you can check whether the data follows a particular distribution. With this, I have come to the end of today's presentation. I request you to subscribe to my channel and hit the like button. Please share my videos with your friends and colleagues. Thank you very much for watching today's presentation. Have a great day. Namaste and a very good morning to all of you. My name is Mithun, and in today's presentation, we'll be looking at two-way analysis of variance. What exactly is two-way analysis of variance? Firstly, even before I answer the question as to what is two-way analysis of variance, let's take a step back and understand as to what is one-way analysis of variance. One-way analysis of variance is an extension of independent sample t-test. One-way analysis of variance is used to compare three or more groups present in one categorical variable. I repeat, it is used to compare three or more groups present in one categorical variable. What happens if instead of one categorical variable, we have two categorical variables? When we have two categorical variables, we can't use one-way ANOVA. We move on to another form of ANOVA, which is called as two-way analysis of variance. Two-way analysis of variance is used to examine the influence of two different categorical independent variables on one scale variable. I repeat, two-way ANOVA is used to examine the influence of two different categorical independent variables on one scale variable. To see how two-way ANOVA works, let me show you how two-way ANOVA works through a practical example. I'm working on SPSS. Let me access a file which is called as grocery_1 month. To do this, I will choose the file menu, click on recently used data. Right at the top, you see grocery_1 month. As the name itself suggests, this file, grocery file, talks about customers who visit a shop to buy grocery items. You can see people's purchase pattern. The first customer, whose ID is 1, is a male customer. He purchases bi-weekly and he purchases in bulk. And the amount that he has spent is $416. Second customer again is a male, bi-weekly customer. He buys in bulk, and the amount that he has spent so far is $383.24. Third customer buys weekly similar items. The amount that he has spent is $577. So on and so forth. As you can see here, if I had only one categorical variable, I would have used one-way analysis of variance. But there are two categorical variables, namely shopping style and gender, to find out what is the impact of these two categorical independent variables on the scale variable, namely amount of money spent. We will be using the two-way ANOVA. To perform the two-way ANOVA, what we can do is go to Analyze. I will choose the sixth option from the top, which is called as General Linear Model. It offers 4 different options. I will choose the very first option called as Univariate. Once I click on the option of Univariate, a new dialog box pops up. SPSS here is asking me for the dependent variable and the fixed factor. The dependent variable will be the scale variable, namely amount of money spent. When it comes to the fixed factor, I can choose gender as well as shopping style. Now, there are a whole lot of options that are present to the right-hand side top corner. You can specify your own custom model here. I will choose the model tab to do this. Let me click on the model tab. A new dialog box pops up. Here, by default, the full factorial model is used. I will choose the second option, namely build terms. I can choose gender and request for the main effect. I also need the main effect for the variable shopping style. And finally, I need the interaction effect of gender and style. By default, the sum of squares that is used to test the hypothesis is type 3. There are other options as well for sum of squares, like type 1, type 2, type 3, and type 4. I will not disturb the default settings. I'll choose the option continue. I will ignore the option contrast. I would like to see a visualization of what is the impact of each of these variables on the dependent variable. So let me click on the option plots. It is asking me for the horizontal axis and separate lines. Along the horizontal axis, I will choose shopping style, and I would request separate lines with respect to the variable gender. So style along horizontal axis, gender along separate lines. Now I can choose the option add. By default, SPSS produces a line chart. If we want, we can also change this to a bar chart. Let me choose the option continue here. Do I want to perform a post hoc test? Yes, I do want to check for the post hoc test. So let me click on the post hoc test. I want to check for the post hoc test for the variable shopping style. You can see here, there are different options when we assume equal variances. I will choose the option cookies test and then say continue. I will be ignoring the EM means method. I don't want to save any new variable. Let me click on the options. Here, I will be requesting for the descriptive statistics. If you want, you can perform the homogeneity test. I will ignore this for time being. We can also evaluate the parameter estimates. I will again ignore this, and I will just choose the descriptive statistics. I'll click on continue. So with this, we are ready to perform two-way analysis of variance. Two-way because, as you can see here, I've got two categorical variables, gender, which is broken down into two groups, namely males and females. I also have the second categorical variable, shopping style, which is broken down into three groups, bi-weekly customers, weekly customers, and people who come often. So let us check what is the impact of these two variables on the amount of money spent by the customer. Let me click on OK. SPSS gives you a lot of output here. In the output window, you see a lot of options. Let me first go to what is called as the profile plot. And as you can see here, this plot is very, very useful to understand what is going on in the data set. As you can see here, in the x-axis, we have the three types of customers. Bi-weekly customers who buy in bulk. Second, we have weekly customers who buy similar items. And thirdly, we have customers who come often and buy what's on sale. You see two different lines here. The blue line corresponds to males and the red line corresponds to the females. The y-axis here is the estimated marginal mean of the variable amount of money spent. In the y-axis, we have amount of money spent. So let us interpret this particular chart. What you see here is very, very interesting. It looks like when you compare bi-weekly customers, men spend a bigger amount as compared to women. So male customers who visit the shop bi-weekly outspend female bi-weekly customers. When you look at the weekly customers, the same trend is observed because male weekly customers outspend female weekly customers. When you look at the last category, this is very, very interesting. The two circles are very, very close to each other, which means that when it comes to the often category, males who come often and females who come often spend almost the same amount. They spend close to $400. So this is the output of the line chart, or what is called as the profile plot. Now, let me go to the descriptive statistics. The descriptive statistics, you can see a lot of numbers, but let us not be intimidated. The descriptive statistics is just a reflection of the numbers that we use to construct the profile plot that you saw here. Let's try to understand descriptive statistics. Here you have males, and then it is further broken down into females, and here we have the total. When we look at male bi-weekly customers, weekly customers, and often customers, the biggest number is 440, and that corresponds to weekly customers. So it looks like male weekly customers who buy similar items are most profitable as compared to the other customers. We also have other important information like standard deviation and the sample size here. Let's look at the female category. We have three groups here: bi-weekly customers, weekly customers, and often. The largest number that I see here is 405, which means, again, from among the different shopping style, females who visit the shop often and purchase what's on sale seem to be more profitable as compared to the other categories. We also have the description of total. Here, bi-weekly customers, weekly, and often. When we compare, the often customers, people who come often and people who purchase weekly, seem to be very, very close to each other because they spend $404 and $406. If you scroll down, the descriptive statistics and the profiles plot are very, very useful. But if you want to look at statistical evidence, this particular table, that is the test of between subjects effect, becomes very, very useful. As you can see here, we have the corrected model, then we have the intercept, we have the first categorical variable, namely gender, the second categorical variable, shopping style, the third variable, namely the interaction effect between gender and style, is also reported. I have error, total, and the corrected total. I have the type 3 sum of squares being used here. It also gives you the degrees of freedom and the mean square. We also can see the F statistic that is being reported here. The last column is very, very important because this column is the significance level. What we do with the significance level is we take this number and compare it with 0.05. If the significance level is less than 0.05, we can conclude that that particular categorical variable is having an impact on amount of money spent. On the other hand, if the significance level is bigger than 0.05, we can conclude that there is no evidence to suggest that this particular categorical variable is having any effect. Let's inspect this one by one. Let's look at the first categorical variable, gender. And as you scroll to the right side, you can see the significance level corresponding to gender as 0.000. 0.000 is less than 0.05, indicating that we have to reject our null hypothesis and conclude that there is a significant difference in the amount of money spent between the males and the females. So gender is having a very profound impact on the amount of money spent. Let's now look at the second categorical variable, that is shopping style. We can see the significance level being reported here. It is 0.140, which is greater than 0.05. 0.140 is bigger than 0.05, and therefore we fail to reject our null hypothesis and conclude that shopping style is insignificant. The third variable is very, very interesting because here we are looking at the interaction effect between the two variables, namely gender and style. And when you look at the interaction effect and the significance level corresponding to the interaction effect, the value is 0.017, which is again less than 0.05. 0.01 is less than 0.05. Since significance level is less than 0.05, we reject our null hypothesis and conclude that there is a strong interaction effect. So these are some of the important insights that we can pick up from the test of between subject effects. That is, shopping style is insignificant, whereas gender and the interaction of gender with style is very, very important. Let's now scroll down and look at the results of post hoc tests. Here, we are doing a pairwise comparison among the three groups. When we first look at bi-weekly customers, we are comparing it with weekly customers. We are taking a simple mean difference between the amount of money spent between the bi-weekly customers and the weekly customers. And when we take the mean difference, that is negative 26.03, is that significant? When you look at the significance level, it is 0.09, which is greater than 0.05. And since it is greater than 0.05, we fail to reject our null hypothesis, and hence we conclude that there isn't a significant difference between bi-weekly customers and weekly customers. What about bi-weekly and often customers? When we compare these two groups of customers, that is people who visit the shop twice a week and people who come often, there is a difference of $28.24. We have the standard error and the significance level. The significance level is 0.193, which is bigger than 0.05. And since this number is greater than 0.05, we fail to reject our null hypothesis and conclude that there is no significant difference between the bi-weekly customers and customers who come often to the shop. We also see the 95% confidence interval being reported. That is, the lower bound as well as the upper bound for the mean difference is reported here. We can see further subsets being provided. This is the output of Tukey's HSD. We can see there are three groups, the sample size and what is the average spend is being reported. Now this I am going to ignore, and we have already seen the profiles plot, which means that a couple of important insights that I can draw. One is that shopping style is not having an impact. Gender is having an impact. The interaction between gender and shopping style is also very, very important. What we can do now is we can go back to the dialog recall. And as you can see here, the last performed action is univariate. The moment I click on the univariate option, the general linear model univariate option pops up. I can go to the plots, and instead of the line chart, if you want the bar chart, that again can be requested. So let me choose the option bar chart, click on continue, and then say OK. These numbers and descriptive statistics we have already seen, but this is something which is new. Either we can report the descriptive statistics in the form of a line chart or in the form of a bar chart. Very, very interesting. You see the three types of shopping style: bi-weekly, weekly, and often. The blue bar corresponds to males and the red bar corresponds to females. For the first two groups, namely bi-weekly and weekly, the blue bar is longer as compared to the red bar, indicating that the male bi-weekly customers outspend the female bi-weekly customers. I can make the same conclusion about the weekly customers because the male weekly customers outspend the female weekly customers. But when it comes to often customers, whether you're male or a female, by and large, the amount spent is very, very close to each other. So this is how we can perform the two-way ANOVA. When we have two categorical variables, we can compare between the groups. We have looked at post hoc tests. We have looked at the profile plots. We looked at both the line chart as well as the bar chart. Depends upon which chart do you want to show. And we also looked at other important information as far as two-way ANOVA is concerned. With this, I have come to the end of today's presentation. I thank you very much for watching today's presentation. If this video has benefited you, I request you to hit the like button and subscribe to my channel. Thank you very much. Have a great day.